Hi folks, this is the first activity in lab number two. Lab number two entirely is devoted to assembly design. So in the first activity, I will do this problem. This is made of three parts: left bearing, right bearing, and the let's call it the shaft. Now it is true that the left bearing and right bearing are identical, and if that is the case, we can make one and then copy it and paste it uh, and proceed. However, copying takes computational resources, and therefore there are other ways of doing it. For example, you copy it, and instead of sorry, you save it. You make one of the bearings, say left bearing, and you save it. And then once you save it, you can say insert an existing component, and uh, basically select the saved component, and it's going to bring it into the display, and you fool around with it. This is a lot more efficient than just simply copying and pasting. For example, if you have a problem which has 100 bolts and you try to do copy of each bolt, well, it can be very cumbersome and inefficient. All right, the only dimensions are not that critical for me. The only thing is I'll make sure that these dimensions these dimensions are respected, and then I'm assuming these are in inches, by the way. So let's go ahead and make it. Now notice that because I'm dealing with an assembly, uh, when the original, the default window that opens up is actually an assembly part or product. Now, I do the top-down approach, and what that means is that uh, I will not create the part separately and then bring it into the product. I will do the part creation as I am in the assembly. In simple problems that we are doing, this is a very simple course. In this simple course, our parts are not that complicated. Therefore, this approach is feasible. So let me do that. I'm going to say, but by the way, let me go ahead and actually save this. I haven't done anything yet, but I will save it. So we go File, Save Management, Save As. Now I do have a folder in here called Lab 2 Activities, and it's going to be Activity 1, so it's going to go in here. So I'm going to call it Product, just that's fine, and then say OK. From this point on, every time I click on this floppy, as long as I'm in the top level, okay, it's going to save everything that I've done. So let's start with the first one. Insert new part in there. Now you can leave it like this. You can call it part one, or you can change the name, for example, to left to bearing. So let me change the name here, properties. So I'll call it the bearing, and this is the part name. Catia does not have a name; it has a number, and this is the instance name, bearing, and we say OK. All right, now to create the part, I have to be in part design. This is not part design. Two gears means you're assembly design. So I expand this thing and I double click on this line. And now notice that I'm putting the part design. By the way, if you see that this is sorry, not grim. If this is dimmed, that means you have selected the tree for some reason. So let me click on any of these white branches. Actually, the thing is no longer dim. Or if you go on, if you go and click on this axis down here, right corner, if you then the dimness goes away. So on this vertical plane, I will sketch something that resembles that bearing. Let me do like that, and we're going to dimension it in a minute. Okay, another circle over here. Okay, so I believe that this thing was 2 inches. If I'm not mistaken, this thing was 2 inches. This radius was 1 inch, and the circle, inside circle, was also radius. Make it radius 0.5. 0.5, oh, 0.5. And we say, okay, there it is, exit. And let me pad it by, well, let's say by, yeah, 1 inch, about that. Okay, so there is my bearing. Now, let me go all the way to the top, right here, all the way to the top. If I click on that floppy, this part is automatically saved. Of course, product is saved automatically, but along with the take, it takes the bearing. So let me say okay, and we're going to check. So remember, I had a folder here called lab 2, and this folder, there is my part. Now, for some reason, I have to change the setting in my computer so that the parts are also shown with the appropriate icon. So this actually should not be like that. It should be something like this, except that there's going to be a single gear. I have to work on the settings. Something is not properly done, and I'm going to fix that. But there it is. There's the bearing. Okay. So let me close that. Let me leave it there. That's fine. Okay, now we can say right click, copy, and then we put it up there, right click, paste, paste. Now notice that a copy of that bearing has been created. Now they're sitting on top of each other. And if you want to see that, so let me go ahead and drag this toolbar out. This toolbar is extremely important for us. And is called move, and this particular one, this particular icon, manipulate, it allows you to translate things and rotate things. So these are translation in different direction, XYZ. These are or any direction that you pick, you can translate it not only in XYZ but an arbitrary direction through this. But here I want to translate in Y, so you click this, put the cursor on it, and drag it. So notice that uh, the two bearings are there. So let's insert the shaft. So insert a new part, and it says, do you want a new coordinate system, a new origin, or the origin of the assembly is going to be sufficient? It's okay. I don't need to create a new origin. I'll say fine. Uh, Click no. The origin point of the assembly, click no to define the origin point of the assembly as the new part origin point. Sometimes you may want to do it differently. In other words, you may want to create a different origin for the part that you're trying to create. But in a simple problem that we're doing, you say no, and that's going to do it. So there is my new part. Right click, properties. I'm going to call it shaft. Shaft and shaft. I say okay. And let's double click on it, and we create the shaft. Now, there's a couple of things you can do. If these are bothering you, you can hide it, but I don't see why it should bother you. In fact, it's going to help me to do my stuff. So on that face, I will sketch. I want to make the shaft, but I'm going to use the stuff that I have in front of me to do that. So I go shaft, cancel, sorry. On that face, you will sketch. Where's the sketch? Right there. Let me take this thing out. There. It says, okay, what do you want to sketch? I want to sketch a circle exactly that size. If that is the case, why don't I project this? Why don't I just project it right there? And exit. Notice that they did project it right there. And I'm going to say, okay, now pad it. I don't know, maybe 10 inches. Very good. Okay. So we go all the way to the top, and we click on the floppy and save everything. Notice that when I go to that folder, I not only have bearing, I also have a shaft. And notice that I said there is some issue with my icon association, and I have to fix this. This should not be blank like that. It should be, a single something of this type. The colors are different, and it's going to be single gear representing that this is actually a part. Okay. So let's move on. Now, There are no constraints defined here. Okay, in other words, I can go to this move right there, and I can move things around. For example, I can move this thing in the y direction, excuse me, or I can move it in the z direction, or z direction, right there. This one in z direction. I can rotate things. Excuse me. So rotate, for example, like that, or rotate about the z. There are no constraints. Okay, so notice what we're going to do is we're going to create constraints. And the first thing that you want to do is to fix something before you create a constraint. That's going to be very beneficial. You don't have to, but it's an extremely good policy. So let me find the uh, uh, constraints toolbar, which is right here. Something wrong with my, yeah, move it down here. This is the constraints toolbar. The first thing I'm going to do is I'm going to fix something. For example, I'm going to fix, I don't know, you can do the shaft, you can do the bearing. In other words, you apply constraints. That thing is going to be put in space. So let me click on the fix icon and select one of these things that I want. So how about doing it as, I don't know, maybe that bearing. As soon as you do that, notice that the tree gets populated, and this obviously, this anchor simply means it is anchored or fixed. Okay, now I want to make sure that this axis is coincident with this axis. And by the way, this is not the only way to do the problem. Okay, I'm just showing you some basics. Remember, assembly design, we're trying to do it in a couple of hours basically. So we say coincidence between this axis and that axis. You have to put the cursor on the curved surfaces so that you select the axis. Now, if I say update, it will line these up and it will not move this bearing because I already fixed it. The other thing is that you can go and change the settings in your options with the options icon so that as soon as you create an assembly constraint, it is automatically updated. Now I didn't do that, but this is the update. This is the update icon. So if you click it, notice that it lined them up so that they're aligned. The axes are aligned. Now, let's say I want to bring this thing and put it all the way to the end. So one way to do that, we say coincident between this face and that face, for example. And these arrows mean something, but let's not worry about it right now. See, these arrows are associated with the same opposite and undefined. So means something. Let's try this as it is right now. That means when you put it together, these faces have the same normal direction. So update like that. Now, if you want to see what is the effect of opposite, so I'm going to double click on it. Uh, say more. You can change it from here, opposite, or what you could have done is that once you double click on this, flip one of these arrows. Let's see what happens and update. You see, what happened? These are not flush. So uh, it'll take you, maybe some practice to get this thing going, or flip the arrows, update, and there we are. Now it's okay. All right, now let's take this thing and put it up there. Coincidence between this axis and that axis, update, and coincidence between this plane and that plane. And again, once if things don't look right, flip the arrows and see whether it works fine or not. This is great, except that, except that I can take, for example, any one of these. See that? I can rotate this about, for example, that direction, rotate about this direction. I can take this and rotate it and say, okay, and it's going to stay. There's nothing to update because there's no constraints between. And there are different ways of doing it. For example, I can make that face coincidence with, or let's say the bottom face coincidence with the bottom face. Or I can say this guy, this plane. Let me see now. I can say uh, this face I can specify the angle between this face and that face. For example, if I say coincidence, update, now they are coincident. But and in fact, you can see that they are coincident. When you look at it, they are coincident. But the problem is that if I rotate, let me rotate about that same direction. When I try to update, it probably goes back to where it was. What I really want to say, I don't want any. Let's make this coincident with the bottom one. Okay, that I think that'll do it. So coincidence between. Let me cancel that for a second. Coincidence between this and that, and then we're going to end up to be coplanar, and it says they are over constrained. So okay, so let's do that. Let me delete this for a second. Remember that last one that I did? Let me delete that. Now we go coincidence between this and that. I'm pretty sure this is going to work out. Oh, no, still no good. So let's see now. Let me turn this thing around. Let me turn this thing around, rotate it about this axis. Okay, good. Can I make this plane and that plane coincident? Coincidence between this plane, oh, cancel that. Coincidence between this plane and that plane. And okay, and update. Very good. Now, apparently there are some constraints here that are redundant. For example, this one, see that? Because of something else that I've done, this is not uh, respected. See that? Needs to be updated. But when I try to update, it won't do it. So let me delete this. Okay. And we can only check. First of all, let me update. No problem. Now, let me rotate some of these. So for example, let me rotate about that piece, and rotate about Z, this piece, and maybe move this thing up in the Z direction. If I update, these should go back to the configuration that I want. Otherwise, something was missing. Okay, so we say update, no problem. So let's do another one to make sure that everything is reasonable. Rotate it like that, rotate it like this, translate. If I update, they should go back to that configuration. So we have a fully constrained assembly. Let me save this and go back to our folder. You see that my product is there, my two parts are there, and that's pretty much it. I want to see something here, whether I can do an association here. I see the tutorial is over, but I want to see whether I can do the association from somewhere. So properties, uh, opens with unknown application. Let me change that. Let me open it with Catia. Let's see if that does it. Yeah, right there. You see? Very good. Hey, good luck.